I'm Mike James, and this is the second tutorial on straight lines and their linear equations. In this tutorial I'm going to show you how to find the gradient of a horizontal line and also a vertical line, and also develop a formula for calculating the gradient of a line that passes through two given points. So first of all, let's have a look at some typical horizontal lines. So I've got two lines here, y equals 4 and y equals minus 3. Remember, a horizontal line is always of the form y equals a constant. Now this line is y equals 4 because it goes through the point y is 4. This is y equals minus 3 because it goes through the point y is minus 3. Well, what is the gradient of these two lines? Well, the gradient of a line is a measure of the steepness of the line, and if you were driving along this green line, which could be a road, obviously the steepness is 0, and so the gradient is 0. So the gradient of any horizontal line is 0. What about vertical lines? Well, here are two typical vertical lines, x equals minus 3 and x equals 5. Any vertical line is of the form x equals a constant. X equals 5 goes through this point, x is 5. X is minus 3 goes through that point, x is minus 3. Now vertical lines have no gradient at all. So try and remember that horizontal lines have 0 gradient and vertical lines have no gradient. Okay, I've drawn a line. I don't know its equation, but it's a diagonal line, and I'm going to develop a general formula that will give you the gradient of any line, provided that you know 2 points through which it passes. Now I've taken 2 points on the line and I've given them coordinates x1, y1 and x2, y2. These are general points. Normally you have numbers, but I'm going to develop a formula and therefore I have to take general points. Now to find the gradient of this line, we can form a right triangle as we did in the first tutorial. Now I've just extended the sides so that you can see what's happening here. Now if you remember, the gradient is rise over run, and we can calculate the rise, which is BC, from these general coordinates, because BC is the same as BD minus AE, and BD is y2. It's the y coordinate of point B. BD is y2, and if you subtract AE, which is y1, the y coordinate of A, you have the rise. So the rise is y2 minus y1. And a similar calculation can be used to find the run, which is AC, because AC is the same as OD, which is x2, minus OE, which is x1. So the run is x2 minus x1. And so we can summarize this by saying the gradient of a line is BC, the rise, divided by AC, which is the run, and we know that BC is y2 minus y1 dividing by AC, which is x2 minus x1. Another way of remembering this formula is in word form. The gradient of a line is the difference of the y coordinates divided by the difference of the x coordinates. Now it's very important that you put the y coordinates on top and the x on the bottom. So let's hide this and have a look at a couple of examples on using this result. So we have an example here. Find the gradient of the line passing through the points A, which is minus 3, minus 5, and B, which is 4, 8. So I'm going to use this result. The gradient of the line will be the difference of the y's over the difference of the x coordinates, or y2 take away y1. Now, what do I take as y2? Now I can start with point A and take y2 as -5, which is what I've done here, and then subtract y1, which is the y coordinate of point B, which is 8. And I divide that by x2, which is the x coordinate of A, which is -3, subtracting the x coordinate of B, which is 4. So -5 take away 8 is -13, divided by -7 gives 13/7. So that's the gradient of that line joining these 2 points. Now, I started with point A when I chose the y coordinate. It doesn't matter where you start. You could have started with point B so long as you are consistent. In fact, I can show you quite quickly doing it using point B as our starting point. So let's see if I can do that very quickly. The gradient, we should get the same answer, of the line equals, and this time I'm going to start with the y coordinate, not of point A but of point B. So I'm going to put 8 in, minus the y coordinate of point A, which is -5. Now be careful here because it's 8 minus -5, all divided by, now because I started with the y coordinate of point B, which is 8, I must now start with the x coordinate of point B, which is 4. Take away the x coordinate of point A, which is -3. Now be careful because you've got to be careful with the directed numbers when I do it this way. Lots of minuses floating around. And that will equal, on top you have 8, 2 minuses give a plus, so 8 plus 5 is 13, and on the bottom 4 minus minus gives a plus, 4 plus 3 is 7. So you get exactly the same answer. So if you compare these two results, it doesn't matter whether you start with point A or start with point B when you use this formula up here, provided you are consistent. If you start with point A, use a y2 is -5, then you must in the denominator start with x2 is -3 and not 4. Don't get them mixed up. Be consistent. But it doesn't matter which coordinate you start with, you'll get the same result. Okay, let's try one more example. You can delete this, and there's one more. Example 2, find the gradient of the line that passes through the points -7, 14 and -2, -6. So I'm going to use the formula again up here, and the gradient, well, I'm going to start with the first point. I'm going to take the first y value, which is 14, take away the y value on the second point, which is -6. Now be very careful with the directed numbers, that's where mistakes are made. 2 minuses on top will give +20. Then I'm going to divide by, because I started with the 14, I must divide by the x coordinate of the first point, which is -7, take away the x coordinate of the second point, which is -2. So 14 plus 6 is 20, divided by -7, 2 minuses here give a plus, -7 add 2 is -5, 20 divided by -5 is -4. So this formula is quite easy to use, but be careful with the directed numbers. Well, I hope you've enjoyed this video on calculating the gradient.